Okay, let's get started. My name is Abby Herzig. I'm the Director of Education at the American Mathematical Society, and I want to thank all of you for joining us for today's webinar on accessibility best practices for moving mathematics online. We're very fortunate to be joined by Volker Sorge. Volker has studied math, computer science, and philosophy at the University of Würzburg. Is that how you say it?
Yes.
At the University of Texas at Austin and University Saarbrücken. He holds a research master's in mathematics and a PhD in computer science, and he is an algebraist working in computational logic. Dr. Sorge is a professor in document analysis and accessibility at the School of Computer Science, University of Birmingham, UK. He leads the Scientific Document Analysis Group, whose research primarily focuses on mathematical document analysis, diagram recognition, and handwriting recognition. For many years, Volker has worked on math accessibility. As a visiting scientist at Google, he integrated math support into the Chrome Vox screen viewer. As a member of the MathJax consortium, he has worked on formula accessibility on the web. Most recently, in collaboration with the Pretext Group, the NFB, and the American Institute of Mathematics, he contributed to the automatic transcription of LaTeX books into tactile Braille books. Volker also manages Progressive Accessibility Solutions, a startup company that is focusing on exploiting pattern recognition and image analysis technology for automatically making STEM diagrams accessible for use in teaching and in science. And with, let me just quickly do some housekeeping stuff. The AMS is recording this webinar. If you participate, you're agreeing that your contributions become part of the recording. Please share any questions by chat. I will pass as many of those along to Volker as I can, but hopefully you can answer each other's as well. And with that, I will turn it over to Volker. Thank you very much.
Thank you very much, Abby. As usual, struggling to share my slides. I think that's it. Right. Right, so thank you very much. Thank you very much for having me in particular. I'm very excited to give this talk in your webinar series. So as Abby said, my name is Volker Sorge. I'm from the University of Birmingham. I'm a chair there in document analysis and accessibility. What are you wondering? If you're wondering what document analysis is, think about scanning a document, trying to understand what's in the document. And what we focus in my group on is particularly scientific content, and that's initially was math, but now we do a lot of other things like particular chemical diagrams, but also physics diagrams, data visualizations, etc. And I'm also a member of the MathJax consortium, and I think it's mainly with this hat on I'm going to talk to you about today. And as Abby said, in my former life I was a mathematician, which gives me a bit of background in mathematics, but it's been a long time. And primarily now I work, the best I do with mathematics is by making it accessible online. And so what am I going to talk to you about today? Well, primarily I want to kind of motivate you to think about accessibility. Now is the time to think about accessibility when you start moving your content online. And it is always the question, well, first of all, what is accessibility and why should I care? And I'm trying to motivate that a bit, that you should care. And I'm also trying to tell you a bit about what accessibility really means in the context of STEM or mathematics in particular. And then I'm trying to tell you a few of the best, or not best, but maybe good practices, I would say. That's always difficult to say best practice when it comes to accessibility of STEM, because there is no real best practice just yet, but they're good practices. And I'm trying to in particular tell you what bad practices are you should avoid. So what is accessibility? Well, accessibility is effectively the idea of overcoming all those barriers that we build ourselves. In particular, when you think about accessibility in an electronic format, on computers, giving people access to data, information, education via a computational environment, then the barriers that we build in this environment are effectively the ones we have to overcome. And there's quite a number of barriers, and some of them you don't necessarily think they might affect you. But so the obvious one is always visual accessibility. When people are blind or have low vision or other kind of vision impairments, they need to have some means of accessing data or accessing information. Another one which is less often talked about is oral accessibility, and that's more for people who are deaf, hard of hearing, or are distracted while hearing. For instance, if you have background noise, you're being distracted, you might want to switch on subtitles in your video, which is normally not that exciting for our particular field when it comes to math accessibility. But if you think about the current situation where people start taping videos or making videos in order to put them online for maybe for the next academic year, taping their lectures, etc., subtitles are really important. And then it's important to actually think about what are we going to do with the difficult bits that are not easily subtitled, i.e. formulas and other things. Another one which people not normally associate with this particular type of accessibility is accessibility of movement, mobility. Mobility is mostly associated with wheelchairs and building a ramp to buildings. But in our case, for instance, is often, can I use a mouse? There are a lot of people out there that can't use mice, particularly if you're blind, for instance, the mouse doesn't really help you. Obviously, that's one thing, but also if you have other problems with limited fine motor skills, etc., then movement is an issue. Another things that are quite prevalent these days is cognitive disabilities, particularly things like dyslexia, dyscalculia, but also other distractive impairments like attention deficit disorders, etc. And the question is always, well, do we really have to care about all these issues? Well, first of all, yes, there are people out there and that would like to have access to material and can't have access to material. And secondly, it's often the law that you have to give people access to material. And finally, if you're a bit selfish, think about it. All of us are impaired at some point in our life. Obviously, once we get older, we might get low vision and all these things, but also think about how you could be temporarily impaired. So just thinking about you want to watch a video or you want to listen to a lecture online, and unfortunately there's noise in the background, so you switch on the subtitles and they have to be good. Or you might be visually impaired temporarily because you're sitting outside in the sun, you have glare on your screen, and therefore you might want to change contrast and all these things. And so from this point of view, accessibility in a way is an important issue, and it's not just for kind of a niche issue for people who are actually physically impaired, but it's important for all of us. Right, now I know that most of you are mathematicians, so you like a clean definition. Unfortunately, I can't give you one because accessibility is difficult to define. It's mainly defined by absence of accessibility. Something is inaccessible. That's easy to spot. Whether something is fully accessible, that's always difficult. That's always up to debate, and it's difficult to assess. So there are accessibility guidelines, the so-called WCAG guidelines, for instance. That's normally the legal basis in most countries these days. To what extent websites have to be accessible, particular university websites, school websites, but also government websites. There's different levels of accessibility, etc. But they are mainly talking about applications and functionality. They never really talk about content. So even though something can be very accessible, it might not be actually accessible enough so somebody can understand anything. So one of the principles WCAG always postulates are what's called the poor principles, which just talks about, are things perceivable? Can I see everything, or can I get to everything? Can I perceive all the information that's on the page, even if I can't see, for instance? Is it operable? Can I get to everything in the page, even if I, for instance, can't use a mouse, even if I only have one hand to use 2 or 3 keys on my keyboard, etc.? Are things understandable? That's generally the question. Is there enough information for things that, for instance, cannot easily perceived? Is there enough information, for instance, for an image, etc.? And are things robust? And robustness in that case normally means, does it work on my on the browser on my desktop the same as on my laptop, as on my tablet, and so on and so forth. Right. So that's pretty much what we are up against. Now, what does that actually mean in terms of STEM content? Well, the unfortunate thing is, even if a web page is perfectly acceptable and by law and satisfies all those WCAG requirements, if it contains STEM content, it rarely is accessible, because that has many things. Some of them I've put here on the slide. Normally, scientific subjects use a very specialized vernacular, which is often difficult to speak, for instance, with screen readers. Doesn't often come across as gibberish. It uses often different scripts from different alphabets and different languages, which is difficult for many systems. It might contain a lot of tables, formulas, of course, diagrams, and what have you. All kinds of difficult structures. So I'll walk you quickly about how things used to be made accessible, and then I'll motivate why that doesn't work anymore. So historically, the way we would make things accessible normally is by giving people an alternative material. So for instance, you would give them a textbook in Braille or in large print, or textbooks would be recorded by expert readers. So you have reading for the blind, for instance, people could just listen to the books. And if you have particular interesting diagrams or illustrations, then you could do this in tactile print as well as swell paper. You give people models and all these kinds of things. And what you then had also to do is that if you have an exam with somebody who can't, for instance, perceive easily what's on a piece of paper, then they might need somebody to actually explain it to them during the exam, and you might need some, say, an amanuensis in order to write things down for somebody with a motor impairment, etc. Now, these days, that doesn't really work well anymore, because obviously a lot of content is in electronic format. And while that is not really the problem, the real problem is that we constantly can prepare material, and it's often prepared on the fly. So you prepare your lecture notes, I don't know, the morning before the lecture, then you put them online. And that just means it cannot be made accessible in the traditional way. So if you think about that, it would take, for instance, between 6 months to 1 year to make a textbook fully accessible in tactile format, i.e. translated into Braille. Well, if you just prepare your lecture notes the day in advance, this is not really a possibility anymore. And the more things move towards web-based learning and learning management systems, that goes more and more away, and people have less and less control over their actual content. And finally, students are normally expected to learn independently, and that means we have to give every student the same chance to actually work through material and understand the material which we want them to learn. And then there's a bunch of extra barriers that we normally do not consider, but that are currently really getting interesting. So in particular, what's a hot topic right now is, how do we subtitle a lecture video? Well, there's all closed captioning, and often that works fairly well. That captions are being produced automatically. As soon as you start pronouncing mathematics or in biology, for instance, proteins or whatever, all these things break down, and then you have to start editing manually. Right. And obviously, well, so what about the current situation? What about COVID-19? Well, right now is really a rush to get everything online. People start preparing their online lectures already for the next academic year, and content has to be made available online quite quickly. Exams have to be put online. A lot of exams, for instance, the UK have been done online, and there is always the problem. Well, if a student used to have an amanuensis to write for them, or somebody to explain them a diagram, you can't have that anymore. With social distancing in place, you can't have somebody come to their home and actually do the job with them. On the other hand, there's of course the question, well, do we have to move quickly to our material online? We have to have it there tomorrow. Then we have more important problems right now than to think about accessibility, because that just complicates things. Well, what I'm trying to tell you today is effectively, first of all, even a rushed job, in my opinion, should be a good job. And at least I know it's not necessarily straightforward to move everything online, and then thinking about accessibility is an extra burden. But what one should, with just a little knowledge, you can do a pretty good job actually. And at least you can avoid doing a really bad job, which means that you have to go back to everything next year, or that you actually lose students because they can't really follow your material. Right, fine. Right. So, I'm sorry. Right, so moving material online, that's the big first part, which I will tell you a bit about, and I will tell you what are good practices, in particular, what are practices to avoid. In order to do this, I'll show you first, I'll show you a bit of an example how math can actually be made accessible in a browser or online. So when I talk about moving things online, I generally mean moving things to the web, because most things now are web-based. Your most learning management systems are web-based. So this is really the big issue at the moment. And what are the problems that we have in mathematics in particular in order to make things accessible? Well, if you think about just say you can't actually see the formula in a page, then you would need to have it spoken. Now the question is, how do you speak that? Well, voicing in a way is a difficult thing for mathematics because, first of all, it's not always straightforward how the expression should be spoken. It depends very much on how complicated and complex the expression is, and sometimes also what the content is, context is. And on the other hand, it's also even a very small expression in mathematics can lead to a lot of words that have to be pronounced, which is quite clearly gives the person that actually has to only listen to the mathematics a disadvantage. And in particular, what it makes difficult is to understand an entire formula in one go. While you are capable of just glancing at the formula, your student probably that listens to them has a much harder time because they have to listen to them in 30 seconds with 200 words, say. So therefore, it's important that we offer people an interactive and an explorative component in for a mathematical formula. And we offer them different views, because views that might be helpful for a blind student is not necessarily the same view that is helpful for a dyslexic reader or for a low vision reader. And then you can give do all kinds of optical tricks in order to make things accessible. And I'll show you how things are being made accessible. So here, this is, so I'm working in a Chrome browser here. And I also can tell you I'm working on a Linux desktop. So this is my computational setup. So what I'm going to use here is I'm going to start a screen reader for you, which is ChromeVox. That is a screen reader which you can load as a Chrome extension, or whether you can run on a Chrome OS or Chromebook. Let me start this.
ChromeVox window 82.43.107.166.
So what you've just heard was the URL of my personal server here. And so that is ChromeVox speaking to you. And we'll listen to the entire page. Let's listen to it.
Section.
Oops, sorry.
Example x equals start fraction negative b plus or minus start root b squared minus 4ac n root over 2n fraction sourced in latex rendered with MathJax accessibility quote built-in quote. Section.
I'm not sure whether everybody understood what was going on there, because it was actually very, very slow for a screen reader. Normally people are blind, read much more or listen much, much faster. But you might have heard that there was, the example was spoken, the text was spoken, in between there was a bit of mathematics. But it was probably, if you're not aware and if you can't see that this is a quadratic equation here on the screen, then you probably will not have got that straight from just listening to this piece of text. So what you can do is actually, you can make this equation accessible by using the accessibility that is built into the rendering of that equation. So what the equation actually is, it is written in LaTeX, in standard LaTeX, And it's just sitting in the page, and then it's rendered with a system called MathJax. And I'll explain to you what that is in a little while. And MathJax also can make it accessible. And let me just switch on. So what you get is you can get an accessibility menu, or you can get a context menu rather.
Excuse me, what was the screen reader you're using?
The screen reader I'm using is called Chrome Vox.
Chrome Vox, VOX?
Yes, VOX.
Okay, thank you.
And so you can switch on the accessibility. You could already hear the text, but you can switch on the accessibility in more detail.
Activate.
Let's do that.
And tick box, not tick 1 of 9.
And the screen readers are always very, very verbose. So yeah, I normally tell them to shut up at some point.
Example source in LaTeX rendered with MathJax accessibility quote built-in quote.
Right.
Section.
Let's go to the equation, and I'll start the exploration mode. And that is just by I'm on the equation. I press
X
return.
Start fraction negative b plus or minus start root b squared minus 4ac end root over 2n fraction.
So what you see there is that it starts highlighting the entire equation, and it starts putting in a subtitle, and it actually reads out that subtitle. So that subtitle is actually hidden in the page. So you can make it visible, you can make it invisible as you wish. And we can now start exploring the expression, because it's still a very long piece of string that you have to listen to there. So let's start exploring it with the cursor keys, so we can kind of dive into the equation.
X equals start fraction negative b plus or minus start root b squared minus 4ac end root over 2n fraction.
Now, you're probably wondering when you listen to this, what is all these words that you would probably not normally say? When you say you write this on the whiteboard or on the blackboard and you speak it out while you write it, you would not say start fraction, you would not say start root, end root, etc. What is all this language about? Well, this language is effectively there to disambiguate where you are in an expression. Consider you're blind, or you can't see what the expression is, you know. And you now want to actually know where, for instance, the negative b is. Well, it is obviously in the enumerator, and you want to know where the fractions ends. You need to know where the root ends, and so on and so forth. So this is one way of speaking. This particular dialect of grammar is called math speak, and is very, very verbose in the sense that it's very good in disambiguating.
How do you open that alternative text? What did you do to make that appear?
I just pressed return.
Oh, that was easy.
And now I'll press the less than simple in order to change a speech rule set. And now we go to a speech rule set which is called clear speak. Oops.
The fraction with numerator negative b plus or minus the square root of b squared minus 4ac and denominator 2a.
And I can hear that this is slightly more natural in a way. This is probably how you might say it in class when you write this equation on the board. And this is a grammar called clear speak, and that's more geared towards high school students. It's more geared towards people with dyslexia, etc. So it's more natural, if you like. Whereas math speak is very verbose, very precise. So it also works very well for large expressions. Right. So this was the quadratic equation. I'll press escape so I can go out. And you can see what you can also see, of course, there's always highlighting going on, which is helpful for people, for low vision people, people with dyslexia, etc.
Numerator negative b plus negative b plus or minus.
And you can walk through all these expressions.
B squared minus 4ac. The square root.
No, that was repeat.
Example source in LaTeX.
Right, let me switch off the screen reader. And it's very annoying otherwise. Right, I'll give you a quick spiel about what MathJax is, because so MathJax is effectively what just did the rendering in the browser. So what MathJax does is it takes the regular sources, in that case it was LaTeX, but it can also accept ASCII math or MathML. And then it generates output that can actually be displayed in the browser. And currently, MathJax is pretty much the de facto rendering solution for the web. And if you, for instance, go to Math Stack Exchange or any of these pages, their content will be rendered with MathJax. The accessibility in the background is actually provided by a system called Speech Rule Engine. So that's my very own system. I originally started implementing the system when I was visiting at Google for a year. And that is being used by MathJax. And it's important to note, and people always confuse this, MathJax is not MathML. It can use MathML, but it doesn't have to use MathML. And that's one of the things I will be emphasizing during the rest of my talk. MathML is not everything we want and everything we need. As a matter of fact, what actually happens when we speak an expression, we do a semantic re-representation of whatever comes in order to find out what operators belong together, where the relations are, and thereby set up a tree which can actually then which can allow you to traverse the expression in a more meaningful way than if you could just linearly walk through the single symbols.
Can I ask a couple of questions, Volker, while we're here? One question is, can it translate from other things like Word and math type?
Yeah, so conversion is the next step.
Okay.
And I will also say a word about math type. Not a good word, but that's...
Okay, so we'll wait for that to come. And then,
yes.
Does MathJax create each of the different speech options automatically?
So yes, MathJax doesn't really create. So that's the system in the background. That's the speech rule engine that creates them. And yes, it does. And you can customize this. And I'm going to tell you about that as well.
Okay. And one other question had to do with pronunciation. When you were doing the quadratic equation, in the numerator, the voice said 4AC, and then in the numerator it said 2A.
Yes.
Is that intentional or?
That is not intentional. No, that is very much, that depends on the text-to-speech engine that is in the background, effectively on the voice that does that. So what unfortunately in English, many voices do is they try to pronounce a single A, not as A, but as A. Obviously, because if you have it in a normal sentence, this is how you would pronounce it. And since text-to-speech, which used to be kind of aimed at accessibility issues and used to be very precise, is nowadays more aimed at the general audience, and people like to listen to a nice voice on Alexa, on their Google Home device, rather than to anything that sounds like a computer or like a robot. That therefore this kind of natural pronunciation is a bit counterproductive for mathematics. That's just fact of life.
And one other question, what about symbols that the students don't know in advance, like you're introducing a new symbol or something like that?
Well, that is effectively up to the author how they do this, right? All that what MathJax does, it renders it and it speaks it. Right. So it can't really decide whether somebody already knows a symbol or not. I'd say. Well, but you have different verbosity modes, which are now not shown, but you have different verbosity modes, and you can customize all of these, where you then say, instead of just saying alphabet, you would say small Greek letter alpha, for instance. But in the normal modes, this is not switched on, because that would just lead to huge expressions, and people would hate that.
Thank you.
Right, and just to mention, because now I've showed, of course, MathJax, but there's a bunch of other solutions out there. Obviously, there's Chromevox itself, which has math support, because that's what I implemented originally. There's some others, JAWS and NVDA with Math Player does math support, as well as Narrator, and Apple, supposed to be Apple here on the slides, is using VoiceOver, for instance. They all have math supports to more or less degrees. Some of them use MathJax, of course, in the background, like JAWS, for instance. And then they have some specialist tools like Equatio and InfiniReader. Again, some of them use MathJax in the background. Some of them use my system in the background, like Equatio. So Chromebooks as well. So in many ways, you might have a choice of kind of the screen reader, but you not necessarily have a choice of how the math is being voiced, because most of it is being done nowadays by us. Right. Okay, now the main question. How do we actually move content to the web? Or how do we move it online, which I normally would say is the same as moving it to the web. First of all, there's different ways to do this. As a poor choice, for instance, or poor choices, that's just by putting printed formats online, linking to your paper on the archive, for instance. Not necessarily helpful. Better choices is if you transform your content to the web. And if you actually transform it into the web format, which is HTML5, you also have a way into ebooks, because EPUB 3 is pretty much the same standard. And finally, the best choice is, of course, if you author for the web. But again, here I would like to say that when I say authoring for the web, I don't want you to change your authoring workflow. I will try to talk about that in a little while more. And I would like to get rid of some of the common myths which unfortunately are out there, and there's a lot of what I would say wrong propaganda. So first thing is, of course, PDF is accessible. Right? I've heard that a lot from mathematicians I've been talking to in the UK over the last few years. No, it's not. Even if it's accessible in terms of the reading flow and all these things, it's very rarely so accessible that the math content will come across. As a matter of fact, there is only very few ways how to get math into PDF. And they in particular don't work with LaTeX, and they hardly work with Word, etc. So PDF is not really something that I'm going to talk about. And there's another myth that content needs to be in MathML in order to be accessible. That's not true. What I've just shown you, the content is in LaTeX. There's no MathML involved. Now, it's a bit of a lie. Internally, there's a structure which is MathML-like when it's being passed from MathJax to this speechal engine. But you don't need to have MathML. You can use your good old LaTeX. You can use other formats like ASCII math, etc., to make them accessible. So obviously from this to kind of a corollary, you could say, is that if all math were in MathML, it would be we would solve our accessibility problem. It's another lie, I'm afraid, because that might work for pretty much any pre-calc, I think you call it K-12 math, and probably undergrad math. But as soon as the math becomes more advanced, MathML just breaks down. And the worst thing that people are being told, in particular by some of their accessibility staff, is often, oh, you have to produce MathML. You have to move away from other authoring tools. And this is just wrong. Don't believe that. Right. So now I tell you how you do conversion if you don't want to move away from and author directly on the website. So there's a bunch of tools which you can use in order to convert your math document. One is particular interesting one is Pandoc. It's a many-to-many translator, which is very good at translating particular Word files, but also LaTeX files or other formats like Markdown. There's another one called LaTeX ML, which is, but obviously, as the name suggests, exclusively for LaTeX, but it translates very well into web formats, particularly HTML5, but also other XML formats. And there's a bunch of others, and there's some more obviously Markdown editors which support math, etc. So there's many of these editors out there, and they all support LaTeX or ASCII math formats. What's better between LaTeX ML and Pandoc, for instance, is that if you have a very involved document which contains a lot of packages in LaTeX, then LaTeX ML might be a better choice than Pandoc. And I'll show you a couple of examples how you can convert a single document. Obviously, I mean, this is just a bit of code which you would normally run on your command line. And it's a single line which translates an entire document into a full standalone HTML document containing math, and that you can render in the browser. You can do the same thing with LaTeX-ML. I'm not going to read out the actual command line. I've just put it there for completeness in case you want to play with it at some point. And you can also do the same for Word, of course, right? You do the same for word sources, and the word math these days is good enough in terms of the structure that it comes out quite nicely in HTML. Now, here's a couple of things you have to be aware of when it comes to converting your content to be available online. So one thing you should definitely avoid are any of these export methods that you might find in packages like LibreOffice or in Google Docs. They tend to just swallow up your math, or just even worse, put it into a picture rather than an alt text, rather than something that you can actually work with. And not an alt text. And yeah, they put it in a picture, sometimes with an alt text, but nothing really you can work with online. Another thing you should stay away from are online tools. Even if they promise you clean HTML, they generally isn't clean, and generally they can't do math. And if possible, I know it's not possible for everybody, but avoid tools like MathType. Why do I say that? Because the problem is that MathType leads to a lot of clutter. Because obviously it's an automatically generated content, which is it's rather, well, let's put it this way. It generates MathML, but the MathML is very poor, and we have to do a lot of cleaning up, and quite often it's geared very much towards visual representation and not towards accessibility.
A couple of questions before you go on, please.
Before I do the good practice, yes.
Is there a text-to-speech screen reader accessibility for LaTeX Beamer presentations? Did I say the right thing, Sachin?
Well, LaTeX Beamer, well, it depends on how you do the LaTeX Beamer. If you have it in PDF, so if you do workflow LaTeX PDF or PDF LaTeX, no, I'm afraid not. But if you, for instance, use Pandoc, Pandoc has a Beamer option. And I think I'm saying that later. Pandoc has about 90 different options to customize everything the way you like it. And yes, it has a Beamer option, which allows you to translate your document, your LaTeX document into online slides. And obviously that supports MathJax. Is there another question? Because otherwise I show how you can support MathJax directly with Pandoc.
Just one quick one, the command you showed earlier, where do you put that for translating a Word document?
Where do I put this? Well, this is point number 5 on this slide.
Okay.
Do not be afraid of the command line. A lot of the tools, or all of the tools I show you here, none of these are there to sit on your desktop and you double click them. They all work on the command line. I know a lot of people are afraid of that. And what I always tell people is, I know it seems like a learning curve, but once you've done that, you don't ever want to go back, because what it allows you to do is convert content in bulk, in particular by documents, many documents at once, if you like, rather than doing equation by equation, which often happens if people just kind of, they take the LaTeX equation, they put it in a system, I don't know, like MathType, but there's other translators online, for instance, then they get MathML back, then they put this somewhere. This is just, this is just a waste of time, a waste of human life, I feel, which shouldn't be done. So yes, all these commands that I have here, you just put in the command line. Depending on if you're working on a Windows box, you open your PowerShell. If you're working on an Apple, you open a terminal. If you're working on a Linux box, you open a terminal. On a Chromebook as well. And if you have Pandoc installed, obviously that's a prerequisite, then all you have to do is write a single command line, and it does it for you. And what it can also do, apart from translating things like Beamer, it can also immediately put in MathJax for you. That is a single additional line in the code which downloads MathJax from the web, so you don't have to do anything, and it renders things for you. And that's particularly important when you are writing documents and you're trying just to want to see how it looks like and whether it's accessible, because there's always this thing about if you can convert and test often, just to make sure that everything always works nicely. And the other bits of advice I would like to dispense here is always retain your sources, please. MathJax, for instance, but also other systems can do so much more if we know, for instance, what the underlying LaTeX was than what if only the MathML is left. Even if you have to go to a different format because somebody requires it to you, there's tools that allow you to keep the original source, say, as an alternative text or as an alternative in an attribute in whatever MathML or whatever the XML format is you need. And another tip is generally try to postpone conversion as long as possible. Keep information around. It makes life so much easier for the people at the back end like us. And then, of course, one thing you should always think about is, well, try it yourself. Why don't you try it yourself? Why don't you try to, if you have a document and you've put it online, just make sure that it's at least partially accessible. But the most basic things about accessibility work. One thing is, for instance, well, zooming is something that's easy to try out. All you have to do is you have to just zoom in and out of your document a bit. And I'll do that here. And I know my document here is in that case not accessible. I think it will break, but I'll do it anyway. So I'll just zoom in a bit. Oh, now I'm at 110%, and all of a sudden the document is entirely different, right? Now I go out, I go a bit further in, and actually now I can see something again. And so you can see, right, how things are switching and changing. That just means it's not particularly well designed. It's not robust in terms of zoom. Right, this is what happens here. Because all the slides are next to each other. Then another one is particularly important for people with low vision or with just say central vision and other things. They need high contrast. There's, for instance, in Chrome, there is an extension where you can change colors. And so I've put 3 colors here next to each other, and I shall switch on this extension now. And that is just, you load it into your page. I think it's one of these up there. I think it's this one. And it's a single keystroke. It's Shift F11. And this is what happens. It's just, all it does is it inverts the colors. There's different ways how to achieve other contrast effects as well. But think about these 3 colors down here, how they've changed, right? So now imagine in your paper or in your document you've written somewhere, well, in red is this and in blue is that. Now, obviously, once you change the color palette underneath, it changes entirely. So it's no longer meaningful. As a matter of fact, it might even be wrong, what have you written? Right? So always be aware that not everybody looks at things in the same way you do. Not everybody wants a white background. Many people prefer a black background, etc. I do, for instance. Another thing that's always easy to play with, and that's particularly important if you put things together like tests, etc. Can you reach everything without a mouse? Can I go somewhere with a keystroke? And for instance, here I'll just the easiest test in the book is just tap through things, right? You can maybe see now that I've tapped to the mathematical formula. Now I've tapped to the answer, and I suppose the answer is something like plus, what is that, 2x? And then I can tap to the answer and I can fire that off, and obviously nothing happens here, but because this is just a demo. Right, so all of these things are easy it's very quick. You don't really have to do anything and you don't have to install much. If you do a bit more, if you want to do some more things, you can use your browser in order to simulate different form factors like tablets and mobile phones where the things still work. You can do screen readers. Screen readers, as you've just seen, they exist as Chrome extensions, but they exist on every platform, particularly if you work on an Apple. Command F5 is very quick to switch on and off. If you have modern Windows 10, I think Windows Enter switches on and off narrator. And that way you can already do a quick test whether the rudimentary accessibility is there in your page. Right. I think I'm mindful of the time. That's why I'm not going to go into details of customization. Customization is important. There are already a couple of questions to it, and often you can fine-tune your web page very much to what you need. And that's particularly important for things like if you want to explain something in more detail, or actually in less detail, say if you want to put together an exam and you don't want that much information to go out, then you have to make sure that not much information is being presented. Other modalities. Here's a nice little vector calculus equation that looks slightly more complex, of course, than the quadratic equation. And I'll just, let me try this, and again, you can see the focus bar around it. Now, I don't switch on the screen reader because that's a very long expression. But what I'll do is I'll just press enter. And what you can see here, I hope you can see, otherwise shall explain. There's a subtitle, and the subtitle contains a Braille line. Now, this Braille line I've only made visible for this demo. Normally it's not visible, but if your student or you have plugged in a Braille display, that would automatically be sent to your Braille display. Right? So you can tactily follow the formula, which is often very helpful, in particular for a large formula like this, which is about, in Braille, I think is about 60 keys, whereas in voice, it's probably about 100 words, probably more. Other modalities you might be interested in are things like summarizing and abstraction. So we have abstraction, ways to abstract formulas, for instance, which is quite useful for dyslexic students. Whereas now I've just collapsed everything, all the summands. Right, so now you can see it's a sum with 3 summands, and that's it. And if I would turn on the speech as well, you could then also see that you can do a summary of this. So it would tell you that on the right-hand side of the equation is a sum with 3 summands, and then you can obviously then walk into those, and you can collapse some of them, etc. Right? So if you have problems with too many simples, in a way, then this is a way to disambiguate that, or to simplify a formula. Now, what we also work on these days is, of course, the subtitling is an interesting subject, which is quite new, which really only cropped up this year. You can generate speech with the speech rule engine for this. I've put a link into the slides here, and then splice in that speech into your subtitles. Other things that you can do. Well, we move things to the web. Now you might as well move things to an ebook. The difference is when you're on the web, everything works dynamically. You can download things like the accessibility extension, the MathJax rendering from the web. You just put a single line of code on your page, and everything will be rendered automatically. When you're offline, when you're on an ebook reader, for instance, you can't do that because these environments are offline and they might not have the same facilities. So what you do is you can use the same conversion workflow from your LaTeX or whatever, from your Word document to get an HTML5. But then what you then can do is you can pre-render all the math elements in there. And preferably the best practice there is you pre-render them to SVG, which is scalable vector graphics, which is supported by most modern ebook readers. And you can also generate what we call deep speech, which is speech expressions for all the sub-expressions in a mathematical expression, not just for the whole expression. Obviously, what you can't do is dynamically switch between speech rules, etc., because that would be, as you can imagine, that would be an exponential problem, right? If you were to put in all possible speech output. And again here, my plea: try to convert your math as late as possible. The later we get the math, or particular MathJax, but also other systems, the more you can do with it. Another problem these days is, of course, learning management system. A lot of the learning management systems do math support. Many use MathJax, things like Blackboard, Canvas, Moodle. It often depends on your local setup whether certain features are available or not. But now that you're kind of aware of what those features are, you should look out for, you can then actually go to your technical staff and say, why doesn't that work? It should work. I know it works. You know, it works in MathJax Pure, for instance, or it works in KTech Pure. Why doesn't it work on my Canvas or my Moodle installation? And then things can be the customizations can be adapted accordingly. And again, what I would like to point out here, what is particularly important for learning management system, if you put together quizzes and the exam questions, always make sure they're keyboard accessible. Always make sure that the math is keyboard reachable so people can actually explore it in detail. Right, I'm mindful of the time. I have tons of additional advice for you on how to author for the web. And I think I might just say how you should author math for the web, because obviously there's a lot of guidelines how you should author in general for the web. Very few in how you should author math for the web. What I always would like to stress is try to keep it simple, right? Avoid authoring for print. I know we all like to move our symbols around until they're really nice in place and they look really great on this A4 or letter paper. But often when you then move them to the web, all this breaks down. And in particular, I've seen colleagues do it, if you start overlaying symbols in order to get another symbol, for instance, that all this really is bad for accessibility. It's always best to kind of leave the spacing to the layout engine because it changed from format to format and from zoom level to zoom level anyway. And when you're using LaTeX, avoid homegrown macros as much as possible, and also reduce the use of specialist packages because conversion will be harder the more difficult packages you use. However, there's a couple of particular MathJax supports a couple of standard packages for chemistry, for physics, for logics, like proofs, etc. If that information is in the page, we can do a lot more when it comes to accessibility. There's a lot of other things you should avoid, but I'm not going to go into all of these in detail. The last thing I would like to talk about is, what about diagrams? All we've been talking about with with formulas now. On there also diagrams. Math contains a lot of diagrams, other STEM subjects even more. Diagrams is always a difficult one. Right now, there is no general solution that will do everything for you. There's a couple of solutions. For instance, there's tab accessible SVG charts from HighCharts. We have worked on a package for certain statistical diagrams from R. The general rule of thumb here is try to export things in a format which is good for the web. Do not try to put things into bitmap graphics, i.e. into JPEGs, PNGs or whatnot. Put them into SVG format that at least gives you some way of making it accessible. And I'll show you one of the diagrams, which is not on the page. Sorry, so I can't show you that. That's a shame. I thought I had it on the page. Nope, it's gone. Oops. Right. So sorry about the diagram. That would have been nice. Right, but let me conclude. Maths is actually not too difficult to move to the web. Math formulas, at least. If you keep, and you don't even have to change your authoring workflow, by all means, do not listen to people who tell you, oh, well, we don't want LaTeX files. All we want you to do is give me a Word file. If you're already working in LaTeX, just keep working in it and use the right conversion technology. That's much better than changing your own habits. What you should change, however, are your inaccessible habits. Things, as I said, if you use all these this macro package that you've curated for the last 20 years, might not be that easy to work with. Make things future-proof. And the way you make things future-proof at the moment is by leaving as much as the original information in as possible. As I said, I've stressed that before. Don't throw away your sources. Never. Try to be as as conservative as possible when you do conversions, and then leave things to the engines out there that can actually deal with this, rather than curating things yourself. Yeah, so that is it. Thank you very much. Apologies that this diagram isn't in the page, which is a bit annoying, but.
Thank you so much, Volker. We have time for a couple more questions, and those of you that leave, we have a brief survey that you should be redirected to when you leave. And one of the questions in particular that we ask is whether you would be interested in an offering of more detailed training than the overview that Volker just provided. So please give us that feedback on your way out. One question we have is that when people present, they often say different things than you see on the slide, right? You're narrating. So if you want to make presentations accessible in real time, can you recommend some good practices? It seems hard to interleave multiple modes like slide reading and speech captioning, or even to have someone hear an image description while they're listening to a speaker.
So closed captioning is very difficult to do. So we've worked with I can't remember the name now, 2 years ago. Anyway, so there's tools out there that do closed captioning for you automatically, obviously, and they're often quite good. They always break down in math. One of the things that I would recommend as to make things easy on you is say a particular word before you do anything with math, like something like start math, something then if you actually get the subtitle printout, that you can find that easily and can replace whatever gibberish is in between the start and the end with the expression that you translate automatically. So you have the actual expression that you put on the board, maybe it's already in your handouts anyway. You just have it in LaTeX, you translate it into a speech string and then splice that in. This is currently, I'm afraid, pretty much the best way to do this. There's the Equatio tool, which you might be heard of. So they have some voice recognition for mathematics, but it's not, obviously it doesn't work with subtitling yet, but it is, if you can use that, for instance, in parallel, but it is a bit, as you can imagine, it's a bit fragile, and it's mainly geared towards undergraduate or kind of K-12 math, high school math.
So I know it's top of the hour and some people have to leave, but Volker, if you have a few minutes, we can keep going with a couple questions. Are you able to stay for a little bit?
Yeah, I can be around. I mean, I don't have to eat dinner before 9. It's no problem.
But great. I got a question from someone who's attending in the middle of the night. So if you're still here, we thank you for your fortitude in sticking with us. This, I assume, is from someone who's working as a TA. What would be your suggestion if an instructor gives you a handwritten PDF and says that they would like to put it online? What would be the conversion flow in that scenario?
For a handwritten one, oh, that's always a good one. Yes. Handwritten is very, very difficult, right? In particular the mathematics. I mean, we've done some work in our group, and it was never very successful. Honestly, it depends on what you're good in. It's the best conversion workflow is probably if you have the time to type it out, just type it out in LaTeX, because it will kind of be, it will be beneficial. If you don't have the time, there are tools out there that try to do handwritten OCR, which probably will not work on the math. You can try the Infty tool, but I don't think they have, I've put Infty on one of my previous slides, but I don't think they have handwritten math recognition. Equatio has some, but I think it's all online recognition. So online as opposed to from a still paper or PDF. So, and then, you know, if the text already is being recognized, at least in parts, then just type out the math equations. Yeah, handwritten stuff is always difficult.
There's been some mention in the chat, but sometimes you just need to scan it and post it as handwritten. But of course, that doesn't allow you to add the other features to it. Yeah.
Even worse than regular PDF.
Right, right. One question is, if you can't see or if you're visually impaired, how do you know where to click to get the auditory, to get the narration?
No, you don't click at all. You go through it by keyboard. So let me just, so, yeah. Oops, no. So for instance here, this is, I've just tapped to the next link, for instance. I can tap to a math expression. Can you see that? That was just keyboard. I'm not using a mouse. I have severe RSI. I'm not good with mice either. I do most of my work on keyboards, also even in a browser. And then space, for instance, opens the context menu. It will be spoken out. I've switched it off now, of course, but you can listen to what the entries are, and then you can switch on and off things. And once you're there, you can also just press return. And so there's no clicking involved. Everything is keyboard accessible. That's very important because a lot of people cannot use a mouse.
Okay. Is there any application that'll turn speech into LaTeX? We're trying to stump you.
I know. I mean, I'm just thinking whether Equation, I know that Equation turns speech into math, into their own format. I'm not quite sure whether this is LaTeX internally or not. I would have to see. So Equation might be one. I'm just thinking about the other question again, because I know there's a couple of Android apps that can actually do handwritten math into LaTeX. There's, for instance, I think there's the Ideal Reader, which you could look into, for instance. I'm not sure whether any of these are online or offline. Most of them are online because online means that you actually have the information about the stroke rather than offline where you only have the image of the handwritten thing. So there are, yeah, the longer I think about it, the more I recall it. Yes, so the Ideal Reader is, for instance, one you could look into, yes.
Some people have encouraged switching from MathJax to KTEX, K-A-T-E-X.
Oh,
does that support screen readers the way MathJax does?
Okay, well, KTEX, yes. Well, KTEX is kind of a competitive competition to MathJax, if you like, in some way. Not in so all it does is obviously translate LaTeX. It doesn't really do accessibility, which is not good. I don't really want. I mean, if I were David, I could also now mention things about the tech layout algorithm and all these things, but I'm not really an expert there. And I don't want to. It's a good system. And it used to be quite a lot faster than MathJax, and that was a good reason for people to change. Now, this is no longer the case. We've released MathJax 3.0 in October last year. And that is so much faster than everything else. It's a very modern TypeScript implementation. If you want to just integrate small parts, it's very modular. So if you just want to integrate small parts, for instance, into your own pages or into your own workflow, you can do that. It's modular, it's fast, it is great. Sorry, I'm a bit biased, obviously, as you can imagine.
If you start with a PowerPoint, let's say for a lecture, and there are a lot of math equations on that PowerPoint and subsequent derivations from that, is Pandoc a viable conversion tool?
Yes.
In order to put those lectures online?
Yes. From PowerPoint, and PowerPoint is Word, practically, yes. Yes. in terms of the math that's in there. Yeah, it's a viable conversion tool.
Okay. I think I hit most of the questions unless I lost some. This group is very good at answering each other's questions. So just when I was going to ask you something.
Where is the, because I've just found my, on a different side, my diagram. There you go. I'll show you quickly a diagram about, this is from R. Some of you might be familiar with the statistics package R. So I've worked with a colleague, a statistician in New Zealand, Jonathan Godfrey, on it, where effectively you can generate fully accessible diagrams. Jonathan is blind himself. Fully accessible data visualizations, things like box plots, histograms, etc. Let me switch on a screen reader just briefly.
Window accessible chemical diagram.
And so you can.
5 box plots for ozone. Title: box plots for ozone.
And you can.
X-axis: months.
You can explore this. You can get a bit more information.
X-axis with values 5, 6, 7, 8, 9. Y-axis: ozone.
And then you can of course
5
explore.
box plots vertically.
You can explore the box plots one after another.
Box plot for 5 and quartiles in 1, 11, 18, 32, 45 and 1 outlier. Median 18, lower quartile 11 and upper quartile 32. Minimum 1 and upper, whisker 45. 1 outlier at 115. Box plot for 6 and quartiles in 12.
So you get the idea. So this makes it accessible. You can also print it then in a tactile format or in an audio tactile format where you can kind of combine the tactile, and if you press at the right place, it tells you what the box plot is, for instance.
I see a few people raised hands, but if you can put those into the chat box.
Sorry.
Window extensions tab.
Sorry, Chromevox is just not shutting up. Yes, what do I do here?
So another question was about using MathJax in Canvas. Can you activate MathJax for an entire discussion board, including the student posts?
Yes. I couldn't tell you how, but I know it works.
So the idea is to go to your instructional design staff
yes, they have to sort this out. Yes, so there's there's quite good documentation out there. It's community curated, so we don't have any influence on any of these. But yeah, I know that in Birmingham we have it, for instance, in discussion boards and in other places, and well, they messed it up. And of course, I'm in Birmingham, so I have no influence on my own people there. And they messed it up entirely, so it's entirely inaccessible, but at least it renders.
Okay. And final question, what about 3D plots? Can it describe those? When
you say 3D plots, what exactly?
Well, suppose you have a surface that's shown on an XYZ axis, for example.
Oh, something like that. Not at the moment. So MathJax can't do it at the moment anyway. So the only diagrams that we can do are commutative diagrams. We're currently trying to get funding to do TIXI, so kind of all kinds of LaTeX generated diagrams. I've been working in a project with Pretext and the NFB, where we are translating textbooks straight into tactile textbooks, so Braille, and in particular also working on graphics. So that means that you can at least translate some of these, it doesn't really matter what the graphics are, into a tactile graphic. Now that doesn't really help you if it's online, of course, right? So because you still have to send it to an embosser and then touch it. And obviously, as you can imagine, the hardest bit there is if you translate the formulas that might be in the graphics. along the axis, for instance, but also anywhere in the graphics for annotation purposes, to get that into Braille and then put it somewhere where there's enough space.
Yeah. So it can't describe the topological characteristics of the surface or anything like that.
No,
Yet.
I'm afraid no, we can't do that yet. But that would be something I would be really interested in. So for instance, I'm working with my company on these kind of, as I've just shown you with the statistics, these kind of diagrams. And particularly working on chemistry diagrams, we're very good at that, and physics diagrams. Math is always difficult because there is no kind of standard way of expressing things. I mean, even a line graph or something, it's not really a standard way. Yes, you might have an x-axis, y-axis, but depends on the author's choice or whatever the textbook is, how these things look like. So it's very difficult to kind of get a uniform handle on that. Yeah,
right.
but we can't describe arbitrary manifolds. Sorry,
Yeah.
no, not yet.
Yeah, I'm looking forward to when you can do 4D stuff. So please let us all know when you're up to that. Thank you very much, everybody. Please check out our website, ams.org/education/webinars, where you'll be able to find the recording of this as soon as we can get it from the Zoom cloud, which is usually within about a day. It'll be posted there, and you'll be able to see upcoming webinars that we have as well. Volker, thank you so much. Looking at all the comments in the chat, people found this really, really helpful. And we really appreciate you taking the time to offer this to us.
Thank you very much. Well, thank you very much for having me. And yeah, maybe we'll follow that up at one point with some more detailed training so people can actually do everything nice accessible, because now is the time to do it.
Yes, it looks like there is some interest from the comments I've received here. So thank you, everybody. Enjoy the rest of your day. And we look forward to seeing you again.
Thank you. Have a nice evening or day.
Or day, evening, night, morning, wherever you are in the world. It looks like we have people from just about everywhere.
Oh, brilliant. All right. Thank you.
Thank you. Bye.
Bye-bye.